In today's Executives and Dummies series, we are going to look at LLM applications. So the topics we are going to discuss are breadth of applications pre-trained LLMs may solve, Hugging Face, and importance of prompt engineering. There's a running joke about how all CEOs and managers are asking their employees to start using LLMs as soon as possible. The great thing about LLMs is that you actually can get started very quickly on many applications with minimal effort, and then you can improve from there. There are a lot of standard natural language processing tasks where you can find really great pre-trained LLMs. Often open source, they do the task well, and there are well-defined processes for improving them for your applications. So given a business problem, how you start is you map that business problem to the NLP task that it maps to. So it could be conversational, fill mask, question answering, sentence similarity, summarization, table, question answer, text classification, text generation, token classification, translation, or zero-sum classification. And then you pick a model that works for that task. And we'll talk about how to pick that model. So for example, let's say you want to generate summaries for Newsweek. Given a CNN news article, here we are generating summary for it. So the NLP task behind this app would be summarization. So the input would be the article, and the output would be the generated summary. Here's a sample of an NLP ecosystem. The popular one is Hugging Face transformers, which are pre-trained deep learning models and pipelines. And then you have LangChain, which helps you create LLM workflows. The others on the list are NLTK, Spacey, Gensysm, OpenAI, Spark NLP. Now, let's talk about Hugging Face. Hugging Face is GitHub for models, datasets, and spaces for demos and code. The Hugging Face hubs hosts models. You can browse models and you can filter them by various dimensions, datasets, and there are dedicated spaces where you can demo your model and your code. The key libraries include datasets, with the help of which you can download datasets from the hub, transformers, you can work with pipelines, tokenizers, models, etc. Evaluate, you can complete evaluation metrics, and under the hood, these libraries can use PyTorch, TensorFlow, or JAX. Here's an overview of the Hugging Face pipeline. As an input, it will take the news article and it will produce the summary as an output. The pipeline will auto-select the relevant model for the summarization task, apply it to produce the summary as an output. And here's the inside of the same pipeline. So as you can see, from left to right, we have the news article. It goes through the prompt construction, then goes through tokenizer, then it feeds into the LLM, and then it feeds into the decoder, and it produces the summary of the news article. Let's talk about the tokenizer. So as you can see, the overall the task here is take a news article and produce a summary for it. So what does the tokenizer do? So the tokenizer will encode the input text into tokens. The tokens are basically used as a model input, and they'll be converted into the numerical representation. Typically it's vector, and in this case it will be PyTorch tensors. So let's talk about the models. So the encoded input will be fed into the model and it will produce the encoded output, which will be decoded, and the decoded output will be the summary of the news article. Datasets. So Hugging Face has a datasets library. It's one-line APIs for loading and sharing datasets. NLP, audio, and computer vision tasks can be accomplished. The datasets are hosted on Hugging Face Hub. You can filter those datasets by task, size, license, language, etc. And you can also find related models. Coming to model selection, you can pick good variants of models for your task. In the Hugging Face, you can filter based on some keywords, and then you can also consider, you can look for examples and datasets. You can ask questions like, is the model good at everything, or was it tuned for a specific task? Which datasets were used for pre-training or fine-tuning? And ultimately, it's about you, your use case and your users and your data. So you can define KPIs and you can test on your data and users. Here are the typical common models on Hugging Face. As you can see, some of the common ones are Pythia, Dolly, GPT 3.5, OPT, Bloom, GPT Neo, Flan, BART, T5, BERT. Here are common NLP tasks. You can summarize, you can do sentiment analysis, you can do translation, zero-shot classification, few-shot learning, you can build conversation, chatbots, you can do table question answering, text token classification, text generation. Now coming to the sentiment analysis. So example would be stock market analysis. You need to monitor the stock market and you want to use Twitter commentary as an early indicator of trends. So you can kind of, based on the kind of, the tweets, you can summarize them as kind of positive or negative. And coming to translation tasks, you can translate a piece of text from one language, from source language to target language. So here's an example of zero-shot classification. So here, example app would be News Browser, and you can categorize articles with a custom set on topic labels using an existing LLM. So for example, there's a bunch of news articles, and let's say you want to create custom labels like politics, breaking news, sports. So given a news article, it can kind of categorize them based on the labels that you've created. Let's talk about few-shot learning. So few-shot learning means showing a model what you want. Instead of fine-tuning a model for a task, the user provides a few examples for their task, and model learns from it and then does the task. So here on the right-hand side, you can see, for each tweet, we are describing its sentiment. So basically, we are teaching or showing the model, how to, detect sentiment from a tweet. So we give a couple of examples, and then the last two lines, we ask the model to predict the sentiment for the given tweet. The tweet is this new music video was incredible. Now, what does the model think? Is it a positive, negative, neutral, or it doesn't know? Instruction following LLMs. So foundational models, they're trained on text generation tasks such as predicting the next token in a sequence. Instruction following models, they're tuned to follow almost arbitrary instructions or prompts, like give me 3 ideas for cookie flavors, or write a short story about a dog, a hat, and a cell phone. For LLM applications, prompt engineering is pretty important. Prompts can be natural language sentences or questions, code snippets or commands, combinations of the above, emojis, basically any text. Prompts can include outputs from the other LLM queries. This allows nesting or chaining LLMs, creating complex and dynamic interactions. So here is a few-shot learning example. So in the few-shot learning, we basically show the model's few examples, and the model then learns from those examples and uses it to answer the question. So here the question is, given a tweet, predict its sentiment. Now, prompt engineering is model specific. A prompt guides the model to complete tasks. Different models may require different prompts. Many guidelines on the net which are released are specific to ChatGPT or OpenAI models. They may not work for non-ChatGPT models. Different use cases may require different prompts. Iterative development is key here. Now, here are general tips for prompt engineering. A good prompt should be clear and specific. A good prompt usually consists of instruction, context, input, and output. Now, you should describe the higher task with clear commands like classify, translate, summarize, extract, etc. Include detailed instructions. Test different variations of the prompt across different samples, and also ask which prompt does a better job on average. Now, how to help models reach a better answer? Ask models not to make things up, hallucinate, and you can be explicit about this. Ask the model not to assume or probe for sensitive information. Again, you can be explicit about this. Ask the model not to rush to a solution. Again, you can be explicit about this in your prompt. Now, prompt formatting tips. Here are a few tips that you may find it handy. Use delimiters to distinguish between instruction and context. For example, you can use £, backticks, braces, dashes. Ask the model to return structured output. for example, HTML format, JSON, table, markdown, etc. Provide a correct example. For example, return the movie name mentioned in the form of a Python dictionary. The output should look like, then you can provide the dictionary example as in title, and then you can give the value for the title. How to reduce prompt hacking attempts. You can do post-processing filtering. You can use another model to clean the output. You can repeat instructions, sandwich at the end. You can enclose user input with random strings or tags. And then if all fails, select a different model or restrict prompt length. Here are guides and tools for writing prompts. I'll link them in video description.